Radiovalve anodes heat up strongly during their operation. They become red hot in powerful amplifier valves. Big oscillating tubes must have a special water or air cooling of anodes. Otherwise, the anodes might melt down. So why do anodes heat up so strongly? The answer seems to be obvious. Electric current causes heating. Anode current goes through the valve and heats up the anode. Let's look at the internal design of a valve. We may suggest that heating occurs as there is a heated cathode in the center of the valve. But we can ignore this because if the anode was heated by the cathode, then the grid would melt first as it is closer to the cathode. Thus, anode heating is caused by other factors. Passing of an electric current is always accompanied by heat release. Joule's law determines this amount. But the anode's resistance is very small and the released heat is insignificant. This can be easily proved by calculations. For example, the anode's resistance of lamp 6 and 6P equals approximately 0.01 ohm. Anode current does not exceed 40 milliamperes. Thus, no more than 16th millionth of joule will be released per second on the anode. So we cannot say that anode current heats up the anode significantly. But still, the anode heats up and quite strongly. So what is the case? The anode heats up as a result of abrupt deceleration of electrons. Electrons are rushing through the cathode-anode space with a speed of thousands of kilometers per second. Having reached the anode, they continue moving in it, but still with the speed measured by millimeters per second. Electrons collide with particles of the material from which it is made on the anode surface. Electrons give the particles their kinetic energy. It is then transformed into thermal energy, which heats up the anode. Actually, we see the same heating mechanism when current passes through the resistance. When electrons collide with the particles of the material, they give them their energy. However, there will be much more heat released because of the greater speed of electrons. Valve anodes heat up as a result of such electron bombardment. This is dangerous in many aspects. For example, when anode temperature is too high, the metal may emit gas. This will reduce vacuum in the valve and its performance will deteriorate. Anode heating also causes an additional heating of the cathode. This may be destructive for oxide cathodes, which function at a relatively low temperature, as oxide cathodes lose emission when overheated. So how can we reduce anode heating? The simplest way is to increase anode surface so that there will be less dissipated power per unit of its area. But in this case, we shall have to increase valve size, which makes its production more expensive. In order to reduce anode temperature without increasing its sizes, we have to find a way to abstract the heat released on the anode. As the anode is in vacuum, we can do that only by radiation. We know from the course of physics that blackbodies have the best radiation properties. This principle is used in anode cooling. The tests have shown that blackened anodes heat up much less than non-blackened ones of the same material. By using such anodes, we were able to significantly reduce valve sizes and avoid unpleasant problems like their overheating and breakage.